So in this experiment we will study the power delivered by a source at different loads. Simply we have to verify the maximum power transfer theorem. Okay, so we know that this theorem states that the maximum power will be delivered to the load when it is equal to the internal resistance of the network delivering the power. So this is my regulated power supply, and this is RS, this is the resistance of the source, and this is RL, which is the load resistance. So when RS, internal resistance of the source, becomes the load resistance, then the maximum power is transferred to the load. So this we have to study in the verification of the maximum power transfer theorem. The apparatus we need is regulated power supply. We already know this is my regulated power supply, and then we need two resistance boxes, 1 and 2 resistance boxes. This is one will be my RS, source resistance, and another will be RL, the load resistance, and we need to find output voltage across this load resistance, and for this we will use the multimeter. Okay, so we know that the power delivered or power in the load is P is equal to I square by times RL. So this is VL square by RL. So this will be maximum when we have RS is equal to RL. This we will verify in this experiment. So the circuit is very simple, that a positive of the source goes to RS, and from RS it goes to RL, and from RL it goes to the negative of the source, and we will take the output from here. So you have positive of the source is going to the RS, and from RS it goes to RL, and from RL it goes back to this source, and these two wires through which we will get the output across this RL using the multimeter. This is fine. Now for the observation table, what we have to do is observation table is like, first we will fix the RS value 250 ohm. The RS, this the load resistance in source, and we will fix this load, and we will vary this RL, so that we will find out the maximum transfer, and we will see that when this RS is equal to RL, whether the power is maximum or not. So what we will do is fix RS first, 250 ohm. So this is my RS. So I have already put it like 250 volt. Every other key is tight, and then I will supply a constant power supply of 5 volt. So I've already make it 5 volt. So what I am going to supply is 5 volt, all constant DC power supply throughout the experiment, and this RS value is 250 ohm, and then I will vary this RL and try to find what is the output. Okay, so it's very simple that I have fixed this value RS 250 ohm, and then I am going to vary it and find the output voltage in the observation table. So like when I'll make it like 50 ohm. So you can see, let me, this is, so let us put the value of RL to 50 ohm, and then you can see the output voltage is 0.87. So fixing RS 250, for RL 50 it is 0.85, in our case it is 0.87, so we'll write it 0.87. Now make it 100. Let us make it from 50, put it back and make it 100. So you can see the value is 1.47. So for 100 it is 1.45, in our case 1.47. So because we keep on varying the RL value, 50, 100, 150, like here you can see this is 250, the value of RL will be equal to 250. Let's see what is the value of this is my 200 and this is my 50. Okay, so 250 is 2.55, so 250 is 2.252, and we have 2.55. In the same way we go on increasing the RL value, and while you are varying RL and noting down the output voltage, try to calculate the power output also. So if you calculate VL square here and then divide by RL values, you can see the power output. This is constant factor, so you can see this is 14, 21, 24, 25.08, 40, 25, 25.42. So you can see this is increasing, and then at this it is the maximum 24.40, and then it decreasing 0 to 24, 23, 22. So this is the maximum value 20.40, which is as 250 RL. So when the value of RS is equal to RL, the power output is maximum, you can see. And if you plot this value, so if you plot the power output on the y-axis and then RL on the x-axis, you can see a curve like this. So you can see the maximum is here at which is 25 point is, and this maximum goes to value, this is 25. So when RL is 250, when I put the RX value 250, the power transfer is maximum. Similarly, you can do for other values of RS. You can do for RS for 500. You can see you can vary the RL value for 500. When this is equal to this, you can see the power transfer is maximum 12.7, and then before that it increases and it's maximum and then increases. You can take one more. If you plot it, you can also see this, the maximum value is here when the value is 500. Similarly, you can take one more observation for RS 1000. You can see for 1000 this is 6.25, the maximum. You can plot it like this. This is going to be like this, and the maximum will be around, this is your maximum value, and this is around 1000. Okay, so this is this graph and this observation shows that we conclude that the maximum power is delivered from the source to the load when the RL is equal to RS. This is known as the impedance matching, and this is what we have studied, that the power delivered by a source at different load is maximum. So verification of the maximum power transfer theorem is done using this simple experiment, then when RS is equal to RL. Thank you.